Okay, Assalamualaikum and hi everyone. So today I'll show you how to solve linear equations by using Doolittle method. Okay, so we have three linear equations here and we have to solve these linear equations by using Doolittle method. Okay, so for the first step, we must convert these equations into metric form. Okay, into the form of ax equals to b. So for metric A, okay, metric A is the coefficient of x, y, and z. Okay, in the first, second, and third equation. Okay, so the coefficient is the number in front of x, in front of y, and in front of z. So for the first equation, we have 1x. So we have 1 plus 2y. So we have positive 2 and minus 3z. So negative 3. And for the second equation, we have 2x. So 2 minus 1y. So negative 1. And then minus 1z. So negative 1. Okay, and for the third equation, we have 3x. So 3 plus 2y. So positive 2. And minus 1z. So negative 1. So this is our metric A. Okay, and then we have x. Metric x is our unknown. So unknown is what we must find from the equation. So for example, for this equation, we must find the value of x, the value of y, and the value of z. So x, y, z is our unknown. So our metric x is x, y, and z. Okay, so equals to b. Metric b is the solution at the right hand side here. So we have 3, 11, and negative 5. Okay, so this is our first step to solve these linear equations by using Doolittle method. Okay, we convert the linear equations into the form of metric ax equals to b. Okay, and then for the next step, we must find metric of L and metric of U by using this formula. Okay, so the formula is metric A is equals to metric L and metric U. So from this equation, we know that this is our metric A, this is our metric X, and for the right side is the metric of B. Okay, so metric A is here. Metric A is equal to metric of L and metric multiply with metric of U. So the formula for metric of L and U is like this. Okay. Okay, so here we have metric of A. Okay, from our first step here, this is our metric A is equal to, okay, this is the formula for metric L and U for Doolittle method. So for metric L, we have 1, 0, 0, and then A, 1, 0, and B, C, 1. Okay, this is metric L. And metric U, D, E, F, 0, G, H, and 0, 0, I. So A, B, C, D, E, F, G, H, and I is just the notation. Okay, it can be any numbers. So for metric L, for Doolittle method, okay, Doolittle method, matrix L, the leading entry must equal to 1. Leading entries here 1, 1, and 1. And the upper triangle is 0, 0, 0. Okay, and then for matrix U, we have the lower triangle here must equals to 0, 0, and 0. Okay. Next step, we must find the multiplication of matrix L and matrix U. So, we multiply row and column. So, for the first row, okay, for the first row here, okay, we have 1, 0, 0, and then we must multiply with the first column. So, we have 1 times D plus 0 times 0, and then plus 0 times 0. So this is for the first row and first column. Okay, next, first row of matrix L multiply with the second column of matrix U. So we have 1 times E plus 0 times G plus 0 times 0. Okay, and then we have the first row of matrix L multiply with the third column of matrix U. So we have 1 times F plus 0 times H and 0 times I. Okay, so we have done with the first row. Okay, and then we proceed to the next row. Second row, we have A, 1, and 0. Okay, we repeat the same process as in this first row. Okay, so now we focus on the second row. We have A, 1, and 0. Okay, we multiply with the first column of U. So we have A times D plus A times 0. Sorry, just now is A times D. Okay, AD, and then plus 1 times 0 and plus 0 times 0. Okay, and then the second row of matrix L we multiply with the second column of matrix U. So we have A times E plus 1 times G and plus 0 times 0. Okay, and for the last column, we multiply the second row of matrix L with the third column of matrix U. So we have A times F plus 1 times H and then plus 0 times I. Okay, so this is for the second row, and we can proceed with the third row. The last row, we have B, C, and I. So the third row of matrix L, okay, we multiply with the first column of matrix U. So we have B times D plus C times 0 plus 1 times 0. Okay, for the first column. And then the third row of matrix L, we multiply with the second column of matrix U. So we have B times E plus C times G and plus 1 times 0. Okay, and for the last column, we multiply the third row of matrix L with the third column of matrix U. So we have B times F plus C times H plus 1 times I. So this is the multiplication of matrix L and U. And then we must simplify. Okay, the product we must simplify. For example, this first row and first column, we have 1 times D plus 0 plus 0. So we have D. And then this one we have 1E plus 0 plus 0 is equals to E. And then 1F plus 0 plus 0 is equals to F. Okay, and then for second row we have AD plus 0 plus 0, so AD, okay, and then we have AE plus 1G plus 0, so AE plus G. And then we have AF plus 1H plus 0, so AF plus H. Okay, and for the last row, we have BD plus 0 plus 0, so BD. And then BE plus CG plus 0, so BE plus CG. Okay, and the last column we have BF plus CH plus 1I, so BF plus CH plus I. So sorry. Okay, sorry. Okay, so this is the multiplication of matrix L and U after we simplify the solution just now. Okay, so after we get the multiplication of matrix L and U here, we must compare with matrix A at the left hand side just now, this one, from the formula of A is equals to LU. So this is the multiplication of LU, and then we compare with matrix A. So matrix A we have 1, 2, negative 3, and then 2, negative 1, negative 1, and 3, 2, negative 1. So we compare both sides based on their positions. Okay, for example, for D, okay, D at the right hand side here is in the position of the first row and first column. Okay, for matrix A, the first row and first column, the number is 1, so D is equals to 1. Okay, D equals to 1. Okay, and then E, we compare with matrix A, so E is equals to 2. Okay, and then F is equals to negative 3. Okay, then we proceed with the second row. We have AD equals to 2. Okay, AD is equals to 2. So we can substitute the value of D here. Therefore, we have A times 1 equals to 2. Okay, so A is equals to 2. Okay, and then for AE plus G is equals to negative 1. Okay, so we can substitute value of A is 2, and then E Okay, also 2 plus G is equals to -1. So we can get the value of G is equals to -5. Okay, and then we have AF plus H equals to -1. Okay, so the value of A is 2 times F is -3, and then plus H equals to -1. So H is equals to 5. Okay, and for the third row, we have BD equals to 3. So BD equals to 3. Okay, we can substitute value of D. So B times 1 equals to 3. Therefore, B is 3. Okay, B is 3. Okay, and then we have BE plus CG equals to 2. So BE plus CG equals to 2. Okay, value of B is 3 times E. E is 2 plus C times G is -5 equals to 2. So C is equals to 4/5. Okay. And for the last column, we have BF plus CH plus I equals to -1. So BF plus CH plus I equals to -1. Okay, value of B is 3 times F, -3, plus C, 4/5, times H, 5, plus I equals to -1. So I is equals to 6. Okay, after we get all these 9 values from A, B, C until I, okay, 9 values. Okay, we can substitute back into metric L and metric U. Okay, so here I already write the question. Okay, so this is metric L. This is the general formula of metric L. So we have 1 0 0, A1 0, BC 1. So we can substitute back value of A, B and C here. So metric L is equals to 1 0 0. Okay, 1 0 0, A1 0. So A, value of A is 2. So we write here. Okay, 2 is A is 2, and then 1 0, and we have B, C 1. So B and C, our B is 3 and C is 4/5. So 3, okay, B is 3, C is 4/5 and 1. So this is our metric L. Okay, and for metric U, okay, metric U, this is the general form for metric U. So DEF 0 GH 0 0 I. So we substitute. For the first row, we have DEF. So our D, E and F is 1, 2 and -3. So 1, 2, -3. Okay, and then we have 0. Okay, so G and H. So our G is negative 5, H is 5. So we substitute here. And we have 0, 0, 0, 0 and I. So our I just now is 6. Okay, so this is metric U. Okay, metric L and metric U. Okay, so next step, okay, for the next step, okay, we know that from the our first step just now, we have the equation of AX equals to B. Okay, metric A times metric X equals to metric B. And then we also have metric A is equals to metric L times metric U. So AX equals to B and A equals to LU. So I write it here. Okay, so A is equals to LU. Okay, I denote it as equation 1 and AX equals to B as equation 2. So from these two equations, we can see that we can substitute equation 1 into equation 2. Okay, because here we have A. So A here we can substitute with LU. Okay, A is equals to LU. So our new equation here is from AX equals to B. Okay, so our new equation here is LU. Okay, because A is equals to LU. And then we have X equals to B. Okay, so this is our new equation. LUX equals to B. So I denote it as equation 3. Okay, and then we let Y equals to UX. So from equation 3, we have LUX equals to B. So for the left side, we have UX. So UX here we can substitute with Y, because Y is equals to UX. So our new equation here is L. Okay, UX we substitute with Y. So LY equals to B. Okay, so now we must find metric of Y. Okay, so L is the metric that we get just now. Okay, L is 1, 0, 0, 2, 1, 0, and 3, 4 over 5, 1. So this is metric L. Okay, L. And Y, metric Y is just Y1, Y2, Y3. And then equals to B. Metric B is from the first step just now. Okay, this one. AX equals to B. So this is our metric B. 3, 11, negative 5. So we substitute here. Okay. So we must multiply metric L and metric Y, and then equals to metric B. Okay. I'll show you the shortcut. Okay. So the first column is for Y1. Okay. The first column is for Y1. The second column is for Y2. And the last column, the third column, is for Y3. Okay. So for the first row, okay, we must write this metric form, metric equation into linear equations. Okay, to find the value of Y1, Y2, and Y3. So for the first row, we have 1 Y1 plus 0 Y2 plus 0 Y3. Okay, so we can write as 1 Y1. So Y1 plus 0 Y2, 0 Y3. So these two values, we don't have to write it. Okay, so we just write y1 is equals to 3. So our y1 is equals to 3. Okay, and then for the second row, we have 2y1. So 2y1, and then plus, because here is positive 1, so plus 1y2. We can just write plus y2, and then plus 0y3. So we don't have to write y3, and then is equals to, okay, 11. So we substitute value of y1. So we have 2 times 3 plus y2 equals to 11. So our y2 is 11 minus 6 is 5. Okay, and for the last row, we have 3y1. So 3y1, and then plus 4 over 5y2, and then plus 1y3. Or y3 only is equals to negative 5. So we substitute value of y1 is 3, and value of y2 is 5, plus y3 equals to negative 5. So y3 is equals to negative 18. Okay, so this is our metric y. y1, y2, y3. So y1 is 3, y2 is 5, and y3 is negative 18. Okay, so after we get the metric of y, okay, from equation of y equals to x here, we can find metric of x. Okay, so right, so y equals to ux. Okay, so y is 3, 5, negative 18. Okay, metric u is here. Okay, our metric u is 1, 2, negative 3, 0, negative 5, 5, and 0, 0, 6. Okay, so this is our metric u, and multiply with metric x. So metric x is from our first step just now. We have ax equals to b. So metric x is the unknowns x, y, and z. So okay, sorry. So this is metric y, metric u, and metric x. So we must multiply metric u and x. Okay, so same as this equation just now to find y1, y2, and y3. Okay, we can use the shortcut. Okay, so for the first column is for x. Okay, x. And second column is for y. And the last column is for z. Okay, so we convert this metric equation into linear equation to find the value of x, y, and z. So from the first row, we have 1x. So x plus 2y, because here is positive 2. So plus 2y, and then minus 3z. Okay, so 1x plus 2y minus 3z is equals to 3. Okay, so this is our first equation. Okay, we cannot solve it yet because we have 3 unknowns here. Okay, and we proceed to the second equation. So we have 0x minus 5y. So 0x we don't have to write it. So we proceed with minus 5y and then plus 5z is equals to 5. Okay, so this is our second equation. And for the last equation, we have 0x plus 0y. Okay, so we don't have to write x and y. And then plus 6z is equals to negative 18. Okay, so from these three equations, we can see that the simplest equation is here. Okay, we can find the value of z from the third equation. 6z equals to negative 18. So z is equals to negative 18 divided by 6 is 3. Oh, sorry, negative 3. Okay, negative 18 divided by 3 is negative 3. Okay, after we get the value of z, we can substitute it into the second equation. So we have negative 5y plus 5 times negative 3 equals to 5. So y is equals to y is equals to 5 plus 15, 20 divided by negative 5 is negative 4. Okay, so after that we can substitute value of y and z into the first equation. So we have x plus 2 times negative 4 minus 3 times negative 3 equals to 3. So for x we have negative 8 plus 9. Negative 8 plus 9 is 1. So 1 we transfer to the right hand side, becomes negative. So 3 minus 1 is 2. So our matrix x, y and z. Okay, matrix x is x, y and z. So our x is 2 and then y is negative 4 and the last one z is negative 3. So this is the solution for these linear equations by using Doolittle method. Okay, so I hope you can understand the steps. Okay, and thank you for listening and thank you for watching. See you in the next topic. Okay, assalamualaikum and bye.